Good morning, ma'am.
Morning, ma'am.
Good morning, ma'am. Good morning,
Good
ma'am.
Good morning, ma'am.
Good morning, everyone.
morning.
अनुज भाई माइक ऑफ कर दो अपना।
Everyone, mute yourselves.
Good morning, ma'am.
Good morning. Let's wait for a minute or two for others also.
Okay. Okay, ma'am.
Okay.
I think we should start now.
Okay, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So yeah, we were discussing some of the basics for wave motion. Okay. So we were discussing what is wavelength lambda, what is frequency, angular frequency omega is equal to 2 pi f, where f is the linear frequency, f is equal to 1 over time period. This is the time period of wave, time it takes for the wave to cover one wavelength in length. Okay, so can you tell me the difference between wavelength and frequency?
Ma'am, frequency होता है distance covered by the wave in 1 second.
Distance covered by the wave in 1 second. What is the expression for relation between frequency f and wavelength lambda? Mathematical expression for the relation between the two.
लैम्डा बराबर एफ सी
T is equal to nu lambda.
One by one, एक जन बोलो.
T is equal to f lambda.
T is equal to f lambda. What is V?
T बोला था the velocity of
क्या बोला था?
मैम
C.
फ्रीक्वेंसी इज इनवर्सली
velocity of
मैम फ्रीक्वेंसी इज इनवर्सली वेलोसिटी ऑफ पार्टिकल
Particle. But हम तो wave motion पढ़ रहे हैं.
velocity of propagation of
Ma'am,
wave.
The wave
मैम
speed.
V is velocity
Lambda
of
बराबर
wave.
मैम न्यू इक्वल्स टू 1 upon lambda
Nu is equal to 1 upon lambda. But that is not correct. Nu bar is equal to 1 over lambda, where nu bar is the wave number.
mu
I'm
equals to
asking.
hc upon lambda.
Nu is equal to h c upon lambda. किसने बोला ये?
Ma'am, Abhinav Anand.
This is also incorrect.
h न्यू
H नहीं रहेगा यहाँ पे. Mu equal to h c by lambda.
Nu is
h
equal
नहीं
to
रहेगा
c by lambda.
3 upon lambda
Yes.
Yes, sir.
Or you can write c is equal to nu into lambda.
Lambda.
What is
मैम
c?
proportional to lambda
Speed of light.
Speed of light.
Rate of
Please
light.
mute
And
whosoever.
C मैम C is equals to F
So-
lambda ही बोला.
In someone's background, there is noise coming out. So please mute the concerned person. Mute yourself. Okay, so what you see?
Speed of light.
Speed of light.
Speed of light. So why we are writing C here? Speed of light here. Okay, so we are discussing wave motion and the special case is EM wave. Right? We are discussing
Yes,
the
ma'am.
frequency of EM wave. So EM wave, light is also an example of EM wave. The visible light I'm saying is also an example of EM wave. And we are writing further a special case in vacuum. Speed of light in vacuum, right? What is speed of light in any other medium?
P by mu.
Speed of light in any other medium? P by?
Mu.
No.
P upon refractive index of that medium होता है.
Yes. If you are denoting
Does not
mu
equal.
frequency, so yeah, C by N. You denote refractive index of medium by N. So velocity of light in a medium is equal to C by N, where N is the refractive index of the medium. So velocity decreases, velocity of light decreases in a medium by a factor N, where N is the refractive index of medium.
हम रिफ्लेक्टिव इंडेक्स को तो म्यू से डिनोट करते हैं.
या म्यू से भी डिनोट कर सकते हैं. I heard mu. When you said mu, I heard mu. You can write it N as well. Mu भी लिख सकते हो. No problem.
N भी लिख सकते.
Yes, both. I heard mu actually. Refractive index of medium. This portion you can write. This one. You write on your notebooks. Then we'll continue our discussion. You also write that what is V here? V is velocity of light in medium. Noise frequency. And lambda is wavelength. One of you said that mu is equal to 1 over lambda. Whereas in here, it is not mu which is equal to 1 by lambda, it is mu bar is equal to 1 by lambda. Mu bar is called wave number. This also you write down.
Ma'am, can we say frequency is inversely proportional to wavelength?
Sorry, frequency is inversely proportional to lambda, yes. And the
Ma'am,
proportionality constant.
frequency is inversely.
Yes, yes. What about units? For lambda, what are the units you generally take?
Meter.
Yes, it's units of length, meter, nanometer, angstrom, angstrom. That is unit of length. What are the units of frequency?
Hertz.
Hertz.
Yes. And also one more unit is there.
Second.
Yes, second
Second
inverse. Or the inverse
Nano.
unit of time. Second inverse. 1 hertz is equal to 1 second inverse. And the units of wave number?
Meter inverse.
Inverse, yeah.
Inverse.
Length, less, yes, length inverse, meter inverse, centimeter inverse, generally we take. Most commonly used unit is centimeter inverse. Have you written down this portion? Velocity part?
Yes, ma'am.
Should I erase it?
Yes, ma'am.
Yes, ma'am.
Okay, so now you will tell me what will happen to wavelength and frequency when light travels in a medium. Velocity, you have seen that velocity decreases by a factor n. Now you will tell me what will happen to velocity, frequency and wavelength.
Ma'am, frequency remains same.
And
चेंज होता है
wavelength?
वेवलेंथ कांस्टेंट रहेगी मैम, चेंज नहीं होगी.
Yes. Sorry, repeat.
मैम वेवलेंथ चेंज नहीं होगी मैम, फ्रीक्वेंसी चेंज हो जाएगी.
Okay,
No, ma'am,
anybody else?
frequency change नहीं
फ्रीक्वेंसी
होगी.
कांस्टेंट रहेगा, वेवलेंथ चेंज हो जाएगा.
Frequency constant रहेगा.
Yes, frequency will remain same and wavelength will decrease by a factor of refractive index. Note this down also. The answer is frequency nu will remain unchanged. And wavelength lambda, it will decrease by a factor, and that is, it will become lambda by n. Lambda prime is equal to lambda by n, whereas nu prime is equal to mu. Can you analyze this in the equation for velocity? Like v is equal to mu lambda. Right? Or we can write C is equal to mu lambda in vacuum. And this is for medium. Velocity is equal to mu dash, mu prime, lambda prime. Okay. So how is it is accommodated? C becomes velocity, right? V is equal to mu prime lambda prime. Put the values. What is the relation between velocity V and velocity in vacuum C? V is equal to C. How these two are related? Velocity of light in medium and velocity of light in vacuum. How these two are related? Yes, V is equal to C over N. Yes, C by mu or C by N. Yes. And we have written down lambda is equal to lambda prime is equal to lambda over N. So this velocity is C by N is equal to mu dash is equal to mu and lambda dash is equal to lambda by N. So this relation can be recovered. That is how we can get to know that frequency remains unchanged and wavelength mimics the behavior of velocity. That is, if velocity is decreased by a factor n in a medium, it is the wavelength which is decreased by a factor n and frequency remains the same. As frequency is the ratio of velocity over wavelength. So in both cases, mu is equal to, it is velocity. In this case, in vacuum, it is C, lambda dash is lambda. So that is how mu is equal to mu dash. If you put the values of velocity V in terms of C and lambda dash or lambda prime in terms of lambda, you will get mu is equal to mu prime. Clear?
Okay, ma'am.
So solve this numerical.
मैम स्लाइड पीछे कर दीजिए ना.
Okay. Yes. Yes, Aditya.
And these topics are the parts of our syllabus.
Yes, you will do interference. The third unit is wave optics. So these are the basics for that. Like you should know what is the behavior, because all you have studied this in 12th, but some of you must have forgotten. So I'm revising these topics. But yeah, gradient, divergence, that is why I did not go that deeper into those topics. Those are not part of your syllabus. It's those are the units in code C. Your code is A, CSC code A. That is why I did not go that deeper into gradient and all. I just wrote down the mathematical expression because you should know how to calculate those things. Because in physics, you will like encounter those things. Because like in Schrodinger equation, there will be del operator. That is why like introduced those terms. But yeah, these are a part of your syllabus. Wave optics, there will be interference and diffraction.
मतलब ये सब साइड वर्क है ना, अभी इन सबको फेयर नोट्स पे नहीं
Yes,
लिखना है
yes,
ना.
yeah, yes. These are the basics. But लिख लोगे तो याद रहता है.
Okay, ma'am.
This is not too much to write, right?
Okay, ma'am.
मैम कॉलेज की जो अटेंडेंस खोली थी उसमें ऑनलाइन क्लासेस की अटेंडेंस भी लगेगी क्या?
Sorry.
जैसे मैम जो रिक्वायर्ड अटेंडेंस होती है 75%.
Attendance ये ले रहे हैं. Yes, it will be added. It will be added. That is why we are taking the record now. Attendance report. We are having. Yes, Shivam.
मैम कॉलेज में यूनिफॉर्म भी है क्या?
Yes.
मैम कह रहा हूँ कि फ्रीक्वेंसी और वेवलेंथ का मैम ग्राफ से हम लोग को समझा सकती हैं क्या?
क्या ग्राफ से क्या समझना है? The relation
मैम
between these
फ्रीक्वेंसी
two.
इनके हाँ 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 मैम इनके बीच का रिलेशन।
Okay. So you can write like
कांस्टेंट
mu,
ग्राफ आएगा।
mu is equal to yes, c over lambda. So it will be like hyperbola, and mu lambda is equal to constant, right?
Yes,
You
ma'am.
can think it like
Yes,
xy
ma'am.
is equal to some constant. So graph will be something like this.
Okay.
But that is true for vacuum, right? When you change the medium, the graph like shifted something by some constant.
Okay.
But the curve will be similar, only there is some shifting of the graph. Should I move to next slide?
Yes, ma'am.
Yes, ma'am.
So solve this numerical.
And wavelength is 4431 angstrom.
And wavelength 443 nanometer.
Both the answers are correct for wavelength. Others also solve the numerical.
My speed is 2.26 into 10^8.
Correct.
Frequency 5 into 10 to the power 14 per second.
Correct. Others? Solve quickly.
Frequency 5.092 10^15 second was.
There is a problem with the 10 power. Check the calculations.
And frequency is 5.091 into 10 to the power 14 hertz.
Correct. Okay, so we'll solve it here. Lambda in vacuum is
lambda.
given. So lambda naught is equal to 5893 angstrom. we have to calculate velocity, speed in medium, lambda in medium, and frequency in medium. First of all, we will calculate wavelength in the medium. So wavelength is equal to lambda naught divided by refractive index. And then is given to be 1.33. Refractive index is equal to 1.33 of water. So yeah, lambda naught is equal to 5893 divided by 1.33. So when you divide this, you will get 430.8 or approximately 4431 angstrom. Second part is you have to calculate the speed of light in medium. So V is equal to C by refractive index. C is the velocity of light in vacuum. C is equal to constant 3 into 10 raised to power 8 meter per second divided by refractive index 1.33. Solving this, you will get 2.256
10 to the power 8.
10 raised to power 8 meter per second. Third part, you have to calculate frequency of light in medium. And you know this is equal to frequency of light in vacuum, which is equal to C by lambda naught. C is equal to 3 into 10 raised to power 8 divided by lambda naught, which is 5893 angstrom. So you convert the angstrom into meter. So 10 raised to power minus 10 meter. Solving this, you will get 5.09
091
into 10 raised to power 14 second inverse or hertz. Those who have not solved it, note this down.
Done, ma'am.
Okay. So next, coherent sources. You tell, what are coherent sources?
The sources with a constant frequency, constant phase difference, and
One by
Same
one.
frequency and constant phase difference.
Okay, same frequency and constant phase difference. What if the phase difference is not constant?
incoherent sources, non-coherent sources.
Yes, incoherent sources.
Incoherent sources.
Okay, so what are the conditions to have a constant phase difference? So two sources are coherent if they if they maintain a constant phase difference. What does this mean? Suppose these are two waves. These are sinusoidal waves. Basically, these are ideal. This is the ideal situation. And this wave is shifted relative to this first wave. This is the first wave and this is the second wave. Yesterday also I asked you the phase or path difference between these two waves. What was the phase difference between these two waves?
5/2.
5/2.
Yes, pi by 2. And
Pi by
what about the path difference?
Lambda by 4.
Lambda by 4. So imagine this source emitting such wave number 1 continuously. Like this is an indefinite wave like this. Right? And this is also an indefinite wave from source 2 and it goes like this. So initially the phase or difference is pi by 2 or the path difference is lambda by phase difference is pi by 2 or path difference is lambda by 4 from at point O or initially. As the wave propagates, right, with respect to time, the phase or path difference remains the same. This is called, it maintains a constant phase relation or phase difference. But what if source 1 starts emitting after some time t, it starts emitting wave like this, something like this. From point t, instead of going like this, it goes like this. What will happen to the phase difference between these two waves? Whereas these waves keep on oscillating like this. Will the phase difference change or not? Anyone?
No, ma'am.
How? It changes. Initially, see, these are two sinusoidal waves. Sinusoidal waves are ideal waves. They keep on oscillating same forever. Sine wave is represented like this: A sine omega t or omega t plus 5, like this. So with the time, it keeps on going like this. Similarly for second wave. But what if the source does not emit sinusoidal waves? Then what happens is, yeah, suppose the the light source is such that it does not emit sinusoidal wave, whereas it emits a series of waves. So here, till this region, this is sinusoidal wave. But here at this point, the sinusoidal behavior is destroyed. Now the wave is something like this. It is sinusoidal after this point, but at this point, which is denoted by this red circle, the wave is not sinusoidal. So the result is the phase difference, which was earlier pi by 2 between these two waves. After this, disruption, the phase difference is changed between these two waves now. It's not pi by 2 anymore. So if the source number 1 is emits waves like this, so these two sources does not behave as coherent. These are incoherent sources because the phase relation is not maintained. Can you give me the example for coherent sources?
one red colored bulb or मतलब one colored bulb.
No, it's not. It is monochromatic. That does not mean it is coherent also.
Okay.
Red colored
Headlights.
light emits monochromatic source. Yes, coherent. The one condition for coherent sources is it should be monochromatic. Monochromatic as in you write that is it should have same frequency and constant phase difference. So these are two conditions. So the wavelength is also maintained. Yes, red colored light, it emits monochromatic light, but it does not. It is not necessary that it emits a wave with the constant phase duration. Anybody give me an example of coherent source?
Ma'am,
Sodium
laser
light.
Again, laser, yes. Laser emits monochromatic light as well as it emits light which maintains constant phase relation. Now, while laser emits a coherent light and normal light bulbs or incandescent bulbs, they don't emit coherent light, you will get to know during this semester. So there is a unit, fiber optics and laser. So you will study laser. So you will study how laser emits light. Sorry?
Headlights. Cars headlights.
I'm not able to hear you.
He's saying
Ma'am,
cars.
cars,
headlight.
headlights.
Car's headlight. No, that is also not coherent. See, coherent light, it should be monochromatic first. Monochromatic as in it should have same frequency throughout. The frequency should not change. I'll give you an example how frequency is changing, how it changes.
Speaker.
See, if the wave is, if suppose there is some light source which is
Am I
emitting
tuned
waves
musical
waves
instrument?
like this. Whosoever is speaking, please mute yourself. Suppose earlier it was emitting waves, suddenly after some time it starts emitting waves like this. So this is an example where we can say that frequency is not same, or it is not a constant frequency source or a monochromatic source, where wavelength is changing with the time. Okay, so it is a not a monochromatic source. Frequency is also changing. Also, we compare two sources, so both sources should have same frequency. Suppose in the
X-ray.
Ma'am, laser light.
yes, laser light is an example of coherent source.
Yes, ma'am.
Ma'am, X-ray.
X-ray source. See, if when we are comparing the coherent or non-incoherent lights, we are talking about light sources.
Ma'am,
So
laser
if
light
some
is-
source, yes, laser light is a coherent light, because in laser, you will study how the like light is emitted in lasers. What is the phenomena? How the process takes place in laser light. Normal light bulbs or light sources, why they don't emit a coherent light is, you know how light is emitted from a light source? In tube lights, suppose at your homes there are tube lights. How light is emitted? Does anyone know?
Ma'am, linearly emits.
Yeah.
Pardon.
See, what happens is, suppose in a tube light there are some gases and it is a mixture of gases and some light emitting materials. What does those light emitting materials do? How does light is emitted is, in the atoms of that material there are energy levels where electrons reside, right? So there are particular
Yes,
levels
ma'am.
where when electron makes a transition, a photon is emitted. Suppose there are these two energy levels, E1 and E2. These two energy levels we are considering in an atom. So these are the energy levels of electrons. There are number of energy levels. We are only considering these two to like to give you a picture how light is emitted. Suppose electron was initially in energy level E1. Okay, we provide some energy in any form, like we can provide the energy in electric form, like we give a voltage source such that this electron gains energy and it makes a transition to level E2. So after absorbing the energy, now the electron is energy level E2. What will happen? Will this electron stay in this energy level forever?
No, ma'am.
Why?
No, ma'am.
Why? Why it
Ma'am,
won't stay?
because it is in excited state.
Yes. And what is the lifetime of excited state? For how long electron does stay in excited states?
Ma'am, it takes nanoseconds.
Yeah, it is almost 10 raised to power minus 8 second. Yes, you are right, almost a nanosecond in the range. So the lifetime of excited state is in this range, 10 raised to power minus 8 second. So electron can jump from this higher energy level or excited energy level to this ground state either before this time period. At the maximum, it can stay for around 10 raised to power minus 8 seconds. After this time, it will jump back to the ground energy level. So now the energy
ma'am.
difference between these two levels, it should be emitted, right?
Yes, ma'am. At
So
the
how
time
these,
of
yeah,
returning, it will emit rays
yeah,
of,
it can happen
of
that it
different
can,
colors
yes. So there are number of ways from
at
like
the
in which
according
the,
of their frequency.
yes. So there are number of ways in which this energy difference can be emitted. The first one is heat. It can be possible that heat is generated when electron jumps from the excited energy level to the ground energy level. Second method is light. Light is emitted when electron makes a transition from E2 energy level to E1 energy level. So when light is emitted, if we consider the case of light, so what will happen when electron jumps from E2 to E1? This is E2, this is E1. A photon will be emitted. What is a photon?
Ma'am, it is a packet of energy.
Energy.
Others, you also take part in this conversation. What is a photon?
Small packet of energy.
Packet of energy. Okay. Anybody else? So yesterday we discussed that light has both wave nature as well as particle nature. Right? Light has both wave nature as well as particle nature. So when we consider light in the form of particles, we consider it as a in the form of photons. Photon is the particle for light. And what is the energy of photon?
E is equal to h mu.
E is equal to h mu or hc by lambda.
hc by lambda.
So we can consider light either as a propagation of wave, or we can consider light as a in the form of particles, where the particle is called photon, which has energy E is equal to h nu or hc by lambda. So when electron in an atom, ये जो एटम की मैं बात कर रही हूँ, ये एटम कौन से है, किस चीज के एटम है?
Metals.
No, not metals. So in tube light, there is, I gave you an example of tube light. So there is some mixture of gas as well as light emitting particles. Can you think of one?
Ma'am, light emitting particles.
No, can you give an example?
मैम जैसे गैसेस में नियॉन हो जाता है और आर्गन.
Yeah, correct in some sense, yes. Phosphorus, quartz, etc. Like in sodium lamp, it is the sodium atoms. Mercury vapor lamp, all those atoms I'm talking about. In those atoms, yes, there are energy levels now where electrons reside. So we provide energy. That is how tube light works now. We give power supply to tube light. So that power supply which we are providing, that power supply gives energy to electron to jump to excited energy level. And when they come back to the ground state, light is emitted. You understand the process?
Yes, ma'am.
Yes ma'am.
Yes, ma'am.
Okay. So what we were discussing, yeah?
मैम आपने मरकुरी का एक बोला, वो क्या था?
Mercury vapor lamps are there na? You in the lab you will see there are sodium lamp in a lab experiment. But in your 12th, I think you must have conducted some experiment with mercury vapor lamp. So in how those lamps work, so there is material inside the lamp. Those material have atoms, and in the atoms there are energy levels for electrons. So we give power supply to that lamp. That power supply makes electron jump to the higher energy level, And after a time of 10 raised to power minus 8 second or so, when that electron jump back to the ground energy level, a photon is emitted. That is how light is emitted. But what happens is when these photons are emitted, these are in random direction. It can be in this direction, this direction, this direction. Also, there the phase difference, the phase relation is not maintained. So the light from such sources is like this. It's a series of pulses. Here, it's instead of going like this, it starts something like, instead of going like this, it can go like this. And after some time, it can change the phase. So light from a normal lamp or tube light, that is how we say that it is incoherent light. Because the wave, it does not maintain a constant phase relation. So suppose this is one source and another source you are having. It is showing the same behavior. After some time, it changes its phase. Like this. So you can't predict the phase difference between these two. So these two behaves as incoherent sources.
Incoherent.
Now it is clear?
Yes, ma'am.
You will see
Yes,
in laser light, this disruption, how it is eliminated. You will see how the photons which are emitted in lasers, they are coherent to each other. They are not incoherent. In this case, it goes in random direction. Like there are number of atoms,
कोहेरेंट
right?
सोर्स में
Incoherent
कोहेरेंट
source
सोर्स
में.
में साउंड
हाँ.
मैम कोहेरेंट सोर्स में वेव साउंड वेव भी आएगा ना, साउंड वेव और सनलाइट.
Sound wave, we are talking about electromagnetic waves.
Sunlight.
yes, ma'am.
Okay.
Okay.
So
हम
we will
रेडियो वेव्स
continue.
माइक्रोवेव्स इसका एग्जांपल हो सकती हैं.
Yes, yes.
हम जैसे
It's
ट्यून्ड
not.
म्यूजिकल
It's
इंस्ट्रूमेंट्स होते हैं.
हाँ बोलो.
हम ट्यून्ड म्यूजिकल इंस्ट्रूमेंट्स के साउंड प्रोड्यूस करते हैं, वो भी इसका एग्जांपल हो सकती है.
See, the sound
वो भी
waves
coherent
which are emitted, that is, the nature is changed. If those are radio waves, then there is coherent or incoherent. But if there are sound waves,
हम ट्यून्ड साउंड वेव्स.
yes, then.
मैम
बोलो.
मैम ट्यूबलाइट में व्हाइट लाइट इमिट होता है, वो कैसे?
ओके, व्हाइट लाइट का कुछ पर्टिकुलर वेवलेंथ या फ्रीक्वेंसी होगा, राइट? इन अ स्पेक्ट्रम of frequency or wavelength, it would have particular wavelength or frequency. वो किस चीज पर डिपेंड करेगा? जो एनर्जी लेवल्स लिए हैं एटम में, उनमें कितना डिफरेंस है, राइट? सो स्पेसिफिक एटम्स विल हैव स्पेसिफिक एनर्जी डिफरेंस, राइट?
Yes,
Are you understanding or should I repeat?
मैम समझ
Okay, okay, I will
समझ
repeat.
गया.
Yeah, so energy levels, they are particular to a particular atom. So if we fix the energy difference, we want to fix the energy difference, then those particular atoms we should take. So it is specific to a material. That is why there are different colors are fixed, like mercury lamp. What is the color of mercury lamp light? Sodium light, you know?
Yellow.
Yes, so the specific materials emit specific colored light or specific wavelength light, and it depends upon the difference between the energy levels involved. Okay?
Yes.
Okay,
Yes,
so we'll continue this discussion tomorrow. I'm taking
Okay,
your
ma'am.
attendance.
Okay, ma'am. Thank you, ma'am.
Okay, ma'am.
Okay, thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.